Good afternoon. This is our last presentation, Phase F for Capstone 2. Our project is the electrical sensor white cane. The group is composed by Gustavo Reyes, that is me, and my partner, Jose Abrams. For the outline, we're gonna see the system validation, the over project conclusion, and the overall project recommendations. For the system validation procedure, we're gonna be evaluating 7 experiments. The first experiment is the vibrator frequency. The objective of this experiment is to aim the validation of frequency between 130 Hz to 200 Hz for the vibrator motors. Uh, all the data for the vibrator motor meets with the manufacturer product descriptions, which is a product that is already with a program unit. Uh, the calculation was making the conversion of RPMs to Hertz, which the converting unit of the manufacturer. The speed of the vibrator motor was 12,000 RPMs times the 0.0167. That will be the Hertz in 1 RPM equal to 200 Hertz. So that's the value from the manufacturer of the vibrator motor. For the second verification experiment, that will be the device should be able to complement a minimal risk for the patient, and the system must attend a load analysis of structural mechanism. On the figure 2, you can see the house mass properties with the volume, surface area, and the mass and everything. The figure the figure 3 is the housing material properties, and the figure 4 is the limb mass properties. On the here are the analysis steps for saving the assembly by a step file, then opening the ANSYS 2020, create a new project, double click to the structural from analysis system, open the engineering data for the project schematics from the engineering data, go to the data source and look for the granta materials, and then import the geometry, same create step file to the assembly. On the figure 5, you can see the data source for the granta material, adding the plastic PLA to our engineering data. Here are the continuous steps to work with the figure 6. That is the apply force on the handle grip direction downwards. You can see here the figure that is downward. The figure 7 is the magnitude to 100 Newton, which we calculate this value. And the figure 8 is the equivalent stress and deformation. Measurement of performance for this part of the MOP. Following the result were obtained, the red area show the maximum stress of deformation and the minimum safety factor. For the figure 9, you can see the equivalent stress with their minimum and max values. The figure 10, you can see the total deformation with the minimum and max values. And the figure 11 is the safety factor risk for the patient, concluding a 9.985 of safety factor. Our range was from 1.5 to 2. Here are the simulation of the equivalent stress on the ANSYS 2020. Here is the deformation simulation. And for last, here's the simulation for the safety factor. For the first validation MOP, that will be the third experiment, the objective of this part is to validate that each measurement of performance complying with each establishing data showing that demonstrate that all control components must weigh less than 1.5 pounds. The handle and housing case should weigh less than 2 pounds, and smart cane must weigh under 3 pounds. The main focus is to ensure the lightweight product for the patient comfort. Yes, here you can see figure 15. Here's the Schuler scientific scale that we use to weight all the components of structural and control system. For the mini breadboard, the expected value was from the manufacturer, provided from the manufacturer was 13.1. The value obtained was 12.8. The Arduino expected value from the manufacturer was 25 grams, and the value obtained was 26.2. For the LED light, the manufacturer expected value was 0.3 and the obtained was 0.32. The battery was 45.3, the obtained value, and the expected value was 45 grams. The buzzer The expected value was 1.6 gram, and the value obtained was 1.3. For the jumper cables, here you can see a little difference on number, but the the expected value was for each cable. So we use approximately 14 cables to all the connection of the person. So that's why the value obtained of our experiment is a pretty high by the expected value. The ultrasonic sensor, the expected value was 8.5 and the value obtained was 7.8. And for the expected value for the vibrator motors was 0.97 and the value obtained was 1.8, since it's the same process as the jumper cables because we use two vibrator motor and the manufacturer was only waiting uh, one vibrator motor. Here are the three figures of the jumper cables, ultrasonic sensor, and vibrator motors. The housing case, the expected value was 112 and the value obtained was 110.2. And the housing lead, that is the other part that covers the housing case, yeah, was 112 and the obtained was 109.8, equals 110 grams. Here are the cap and the handle. The cap is the one that it go below the handle, which covers all the vibrator motors. The expected value was 9 grams and the obtained was 8.3, and the expected value was 76 grams and the obtained value was 65.3 for the handle weight. Here you can see this is the electrical sensors marking, which consists all the components inside the handle, and the total weight for our experiment was 0.93 pounds. That is less than 1 pound, but you can equal as a 1 pound. And the expected value from the provider of our experiment was under 3 pounds. So for the measurement of MOPs, all control components should not exceed 1.5 pounds, which our electrical components, the total weight was 0.2434 pounds. The structural mechanism should weigh less than 2 pounds, which was 0.6693 pounds. And the total weight of the structural and electrical components, that was the total of all data, was 0.9304 pounds. This is the table which consists of the validation of weight MOPs. For the next experiments, the overall project conclusion, my partner Jose Abrams will continue with you. Thanks.